So in this second part, we are going to continue with more queries. And by the way, just I found how to switch the coloring. It's under settings, and there's the style something. And for any kind of the language, you can recolor the things. So that's something, some additional thing if you are using Notepad++. So now, last time we were interested in the user that is getting the maximum number of credits, and for some users we are able to use functions, get the maximum, minimum, or the average of some attribute, and we can also use it as a condition if we include it in a subquery. Right now we also have one more example in the handout. Let's write it from scratch. It says that find name, surname, status and credit of the user with the minimum credit. So I know that I'm interested in the user table, and the things that I would like to project, they should be listed after select statements. They are going to be the name, the surname, status and the credit of the user. And I have some condition, and this condition is on top of the credit. So I have some condition for the credit of the users. I want this value to be equal to something, and that something is the minimum amount of credit from the user table, from the same table. In this subquery I can also include some other table. I can get some value from other tables and use it as a comparison value. After this subquery is run, we get just one value, and we can use that value at any place. But this time we are interested in the minimum of the credit, and this credit is going to come from the user table. So from the user table. This is my subquery. When I run it, I get just one value, and I'm searching for the ones that are equal to this value. If I'm using the function min, max, average, or sum, I know that it will just return one thing. Therefore, I can use this equals sign. And if I include this query inside my execute SQL statement window, I will see the results for credit 0, 1 read is returned. Now let's try to mix and match things. So the query says that we need to find name, date of birth and credit of the users who have more credit than the average and was born before 1990. So what we need to find is the name followed by the dates of birth and credit of the users. So still we are looking at the user table only. But for these users, I have two conditions. One is for the amount of credit. So I want the credit to be more than the average. So instead of saying equals to, I want it to be more than, not the minimum, but the average. So this subquery will find the average credits, and I'm searching for the users that are paid more than this number of credits. I also have some more conditions. So it was also saying that, and this user should be born before 1990. So for the date of birth, I have another condition. This date of birth should be less than some year, and remember, for years we include single quotations. So the year, the month, followed by the day. This is one condition. I'm using the AND operation, and this is my other conditions. These two conditions should be true at the same time for these users to be listed. So I will paste it here and execute it, and for these users I see that their credits is kind of high. They are more than the average, and if I look at the date of birth, these are before 1990, and these users are listed because they satisfy these two conditions. if instead of and I write or, now I have 6 users. If I execute this, I have more users. So whether it is the AND operation or the OR operation, it's very important. So we were just using one table for our operations or our queries, but let's use more than one table this time. Let's say we would like to find name, surname, and company name of the users that are partners of companies. So I have a list of users, I have a list of companies. Username and surname is included in the user table, but the company name is included in the company table. And we have this relation partner of that is defined in between those two tables. And this time we would like to use this relation. In the design, we remember we were just including the multiple tables, and if there was some relation in between, it was making the join operation automatically. But in writing directly SQL, we don't have such option. We need to make the join operations ourselves. So in this query, we would like to show the or project the name and surname, and also this time the company name. If you check, a company name is an attribute of the company table. We would like to project these things, but the user table is not enough. The company name is included inside the company table. But if I just have the user table and the company table, I cannot define a relation between these two tables directly. I cannot join them directly. I also need the table of the relationship, which is the partner of table. So let's just get rid of this one. So in the partner of table, I match a user ID with a company ID. So this table is used for matching users with companies. If I don't have this table, with the user table alone or with the company table alone, I don't know which user is matching or which user is the partner of which company. So I need this separate table. In the ER diagram, partner of is a relationship. It's defined in between those two tables. Therefore, to join these two entities, I need the partner of table as well. In SQL query, this order is not that important, so I can also write it like that. But to keep it nice looking, I'm following the order of the links. So user is connected to the partner of, and partner of is connected to the company table. So I'm not saying which is the parent of which table. I'm just saying that links are in between these two and these two. If I go and run this query, it will return lots of results. If I execute it, I actually it's doing something. Okay, maybe it's better to just close it and run it again. Technical problems. Okay, let's just get rid of this one, I guess. How to get rid of your not working LibreOffice. Let me quickly open it again. So it has this recovery option, but since we did not change anything, it's not that important. We were just running these queries. So this is what I wrote there. I would like to show the output. If I execute this query, is it because I have lots of things? I guess so. So from these three tables, in the partner of table, I have a bunch of rows. Actually, it could be like more than 20, I guess. And in the user table, we have 20 records, and in the company table, we have like 10 records. This should not be that hard for it to run, but I guess it's not his, it's best day. Okay, let's just get rid of that. It is going to make a Cartesian product. So if you include the multiple tables and if you are not using the join operation, it is going to make the Cartesian product, and Cartesian product means that every user is matched with every other partner, and for these tuples they are also matched with every other company. And maybe displaying it was the problem, maybe it is conflicting with some of the recording programs, I don't know, but in here we have 33 things. Since we are using the Cartesian product or cross product, it is multiplied with this 20, and it's also multiplied with this 10, which is not that big of a number, but let's come back to here. So it was going to make the Cartesian product or cross product. Every user is matched with every other partner of and every other company entries. But we would like to specify the join conditions. So join conditions are written with where conditions as well. This time from the user table, since I have now multiple attributes, they could come from different tables. Let's first start writing which table this attribute is coming from. From the user table I have the ID, and I want this ID to match with the corresponding part in the partner of table. And if I check the relations view, I see that ID of the user is matched with user ID in partner of, and CID of company is matched with company ID of the partner of table. So in here inside the partner of, what I have is the user ID, and at the same time, since I'm making these join operations at the same time, I should write and. I want the company ID that's inside the table partner of. I want this to match with the company.cid. So one condition to match user with the partner of table, the other condition to match partner of with the company table. So basically I'm making two join operations in between those tables, and these are the attributes that should match. And hopefully if we run this query now, we will see some results. Maybe it was about the execute SQL statements window. Maybe this window is not able to show that many outputs. That could be the reason, I guess. But if I check, so I have William Ramirez twice, but this is, the first one is for O Limited, the second is for Ocean Arts. If I look at the partner of table, I see that user ID 1 is matched with company number 4 and 10. If I check the companies 4 and 10, they are O Limited and Ocean Arts. And if I check the user number 1, it's William Ramirez. So this is what we are doing. We are finding the company names and also the username and surname of the users that are partner of some company. And in here, since we have the unique attribute names, meaning that in user table I have ID, in the partner of table I have user ID. These are different. If they were the same, if they were using the same attribute name, which is sometimes we do, then we need to specifically say that which table this attribute is coming from. But in this case, since the attribute names are different, I can just write the attribute names as well. So there is no problem with writing it like that. If I run this query, it will display the same results. So command successfully executed, and I see the same results. So with the join operation, we can also include more conditions. So let's say that we would like to find the username, company name, credit, and monthly payments of the users that are partner of a company. And for these users, we want their credit to be at least 500. So I have the join operations. I would like to show the name, the company name. Maybe if the ordering is important, let's get it here. The credits, I also want to show the monthly payments, which is some attribute inside the company table. So these are the things that I would like to project. They are coming from these three tables. I need to do these join conditions, and remember, in between these join conditions, it should be AND operation. Otherwise, we have a problem. We want these to make the join operations at the same time. Otherwise, if you include OR there, it's going to still make the Cartesian product in a way. So some of the attributes will match, but some of them will not. So these should be matching at the same time. Something to be careful about. And we have a third condition saying that the credit should be at least 500, and we can just include this criterion here. If I execute this, now I see the users, the company that these users are a partner of, followed by the credit of that user and the monthly payment. And if you check the credits, they are all larger than 500. So they are all satisfying this condition. So now let's try to find the name and credit of the users that live in the same city as a user named Brandon. So we are back to using one table. So now I will do this, select. So let's first find Brandon. I would like to find which city Brandon is living in. So I can write select city from the user table, where this is going to be my condition. I want the name of this user to be exactly equal to Brandon. So I don't need to use the keyword like this time, because I'm not using regular expressions. I want it to match exactly. I know that there's some user named Brandon, and I would like to find the city of this person. If I execute such query, it says that Istanbul. Okay, now I know the city name of Brandon. I can use this as a subquery. So I know that this returns some city name, and in some other query, I can use this city name. So let me do it like this. This is my subquery. In the question, it is saying that find name and credit of the user. So I need to select the name and credit of the users. This is going to come from the user table. And I have a condition saying that these users should live in the same city with Brandon. I know that from this subquery, I get just one city name. And if I run this query, I will see that these are the people. Brandon is also living in the same city with Brandon. But Wayne and Elias is also living in Istanbul, and they are included since they live in the same city with Brandon. So this is one way of solving this problem. Additionally, there is something else to notice, that for now we know that there is only one Brandon, but in future there could be more Brandons in our table. So if there is a risk of returning more than one results for a subquery, instead of using the equal sign, it is better to use the keyword in. So if I execute this query, it will run the same, but the first version will have a problem if we have multiple Brandons in our database. So this is one way of solving this problem. But from the regular expressions, you might remember some other way as well. With regular expressions, we don't have like easy, or let me, for this one actually, okay, with regular expression we can solve it in two different ways as well. But for functions, for example, in regular expressions, I'm saying regular expressions, sorry. I want to say relational algebra. With relational algebra, so remember, we can write queries in relational algebra. These can be converted into SQL, and for SQL it can be converted into relational algebra as well. But in SQL we can use functions, but in relational algebra, in the form that we are using in lectures, we do not have functions, we don't have maximum, minimum, etc. And in such cases, remember, we were making use of cross product with the multiple instances of the same table. And if we would like to find the people that live in the same city as Brandon, we can follow a similar approach. So I would like to select the name and credit. We are still doing the same question. It is saying that find name and credit of the users that live in the same city as a user named Brandon. So these are my projection things. And I also need the user table. But I would like to include two instances of the same table. So I would like to say actually user and user. If I write it like this, then there is no distinction between these two tables. So these two tables share the common attributes, and I need to be able to refer to them separately. To be able to do that, I need to give a name to the different instances. For example, for this one I can call U1, and for the other instance let's call it U2. So I include two different instances of the same table. I rename them as U1 and U2. And now if I would like to project something, since U1 and U2 both have the attributes name and credit, I need to specify which table these values are coming from. So in this case, let's project the one that is coming from U1. So my condition is going to be, this time, on the U2 side, I would like to find Brandon. So I want U2 that's name to be equal to Brandon, and I have some other condition. So for U2 I have the Brandon. It was making the Cartesian product. Every U1 is matched with every U2. But I make a selection for U2. For U2 I only have Brandon. And my second condition is for the cities of U1 and U2 to be equal. So this time I will say that U1 dot city should be equal to U2 dot city. So these two things should be equal. And I will see from the U1 side the other users that live in the same city as Brandon. So if I paste it here and execute it, now I still see the same results. On top of that, maybe I don't want to see Brandon again. So I can add an additional condition saying that, okay, U1, this U1 should not be Brandon. I already know that Brandon is living in the same city as Brandon. Instead of that, let's just show the other users. So that's also possible. If I execute it, now Wayne and Elias is shown, and they are living in Istanbul. For the other one, let's find number of users from each city, and we would like to display the city name along with the count. So remember, we have a function to count the different instances, but this time we would like to analyze something for the groups of people. So actually what we want to do is we would like to show the city names and also the count of the people from the same city from the user table. So far this could be what you want to write. Let's check what happens with this query. If I run such query, now it says that not in aggregate function or group by clause. So what I'm doing is, actually I'm trying to project the count. If I were to just write count here for this query, I can find the number of users. If I write it here, it will display me the result of the number of users. With any function, it was fine. But if I also include some other attributes from the same table, for example, this time I write city here because I would like to show the city name. It gives me the error saying that not in aggregate function or group by clause. So the problem is that from the user table, there are multiple cities, but the count function just returns one value. So this cannot be shown at the same time. Moreover, what we try to achieve is something different. We would like to find the number of users from each city. So for each different city, I would like to show the number of users that are coming from that city. In this case, we need to use the keyword group by. So actually, what I want to do is, from the user table, I would like to group the users according to the city. And for these cities, I would like to project the city and the aggregate function count. For each group, I would like to count how many entries are there. So let's run this first. So if I execute it, I see the tree for the null value. For this null value, there is 3 different instances. There are 2 Izmir, 3 Istanbul, 3 Ankara, etc. You will see that if I use the execute SQL statement window, I see Izmir to Izmir. So the city name is appearing twice. This is only because of this window. So this operates in a way that it shows the group by at the end of each row. But let me just copy it from here, and if you were to use the create query in SQL view, so this is the same query, if you run it here, you will see that the city name is displayed once. So that duplicate city names is actually coming from how that execute SQL window operates. It appends the group by condition as well, but to follow some to be correct, let's say, if I need to include the city name, I should write it next to select, because in other places this is the correct version. So I will go back to the execute SQL statement window. So without the count, let's also show what happens. So if I omit count, if I'm not showing the count of each group, it is also displaying me the groups. And maybe sometimes people think that, okay, I would like to also show who is living in which city, or sometimes people mistakenly think that I can group according to the city, and then I can display the names of these users as well. So this is going to be problematic. Let's try to see what happens. It says that again, not in aggregate function or group by clause. The problem is that if we group by according to some attributes, it can be multiple attributes as well, but there is some restriction on the things that we can project. So let me also show it in the handout to see it in a better way. I actually have this file, but let's get it from here. So what happens actually is that if we are using the group by keywords and using a bunch of attributes for grouping, then we can only project a subset of the things that we group by. So attributes 1 should be a subset of attributes 2, plus the functions. So the functions are a different thing. For functions, I can include as many functions as I want. But for the attributes that I project, they can be the subset of the things that I group by. So coming back to here, if I would like to project the name as well, then I need to group by according to name also. So with group by, sometimes people think incorrect. So if you group both by city and name, then you are not grouping anything actually. Because if you think, the names are in our user table, each user has a different name. If you are to group according to the name, then in each group there is going to be only one person. So let me first do that. If I were to group by name and show you the name of that user, and maybe also show the count of each group, then I will see lots of ones and ones only, because in this table, by chance, everybody has a different name. In some other table there might be some other conditions, but if I am grouping according to the name, in each group there's only one person, and this defeats the purpose of grouping things. So if I would like to show the users along with the city name, I don't need actually to make a grouping. So with such query I can, if I'm able to write it correctly, with such query I can show the user followed by the city this user is living in. With group by, we would like to investigate something. We would like to run some function for the groups. So that's why we include the group by keyword. So with group by, what we would like to achieve is we would like to run some function for each of the groups and display the results. This could be one option. For example, with the next query, let's try to find the number of partner users per company. So in each company there could be multiple partners of that company. We would like to display the results along with the company name. So we would like to show the company name and then the number of partner users of that company. So we are going to solve it in two different ways. If you look at the company table, company name is not the primary key. So it is not unique actually. Meaning that there could be multiple companies sharing the same name. Maybe there is some company with CID 11, it has the same name as Ocean Arts, and maybe some other information is different. So the primary is CID only, and CID is unique. That's what I know. But for the company name, it's not unique. But let's say for now the company name is unique and try to solve it that way. So we are interested in finding the number of partners per company. So the tables that I need is, I need to make the join operation, right? To find which user is a partner of which company. So I need the user. I also need the partner of table. I also need the company table. These are my three tables. Since I include these things, I need to say that, okay, ID from the user is going to match with user ID of the partner of, and I will also have some other conditions saying that CID of company should match with the company ID that is coming from the partner of table. And after I make these join operations, if I say that company name is unique, I can group by company name. So this is one attribute of the company table. I can group according to company name, and I can project the company name along with the number of entries per group. Remember, so without the group by operation, let me first do it like that. So I will get this part, get rid of this count. If I execute such query, maybe I should show more things. Let me also show the name of that person. So this is the company name, this is the user. Users are matched with companies. And if I were to group them according to the company name, then it is going to group the ones that share the same group name. So for example, O Limited, this person is also from O Limited, this is also from O Limited. I guess there are 3 of them, or 4 of them, sorry. So if I were to group them according to the company name, then these 4 entries will be grouped together, and for their company names next to it, I will show the count of entries for that group. So let me run this statement. Now you will see that it was actually 5 then. So for all limited, I have 5 instances. For Nemostar, there are 5 people. For example, for Diamondtronics, there is only 1 partner. Let's check that. So in the company table, Diamondtronics is number 6. And if I check the partner of table, that 6 is going to be appearing only once, and once only. So it is making the groups, and for each company we are displaying the results. But let's say that if I were to say, okay, let me quickly add a new company with the same name as Ocean Arts with some monthly payments, so they share the same company name. And let me also put some users into that table. So previously, let me first check it then. So previously, if I go to the SQL, if I execute this one with the output option enabled, for which one we made a change. Okay, let me check company, Ocean Arts. So for Ocean Arts, actually I guess, okay, for Ocean Arts there are 4 partners currently. But I have 2 different Ocean Arts. The new one is with CID 11, and I would like to make a partner for that one. So let's make user number 1 a partner of this company, user number 2 and user number 3. These are partners of this new company with CID 11. It's a different one, but it shares the same name. So if I run this SQL now, I will see that for Ocean Arts, it shows that there are 7 people, but actually we have 2 different Ocean Arts. So using some attribute that is not unique could be problematic in this case. So with city names, for example, city names, if we have different city names, these 2 cities are different. That's something we know. But for companies, if we don't have such guarantee, then we cannot use such query. Then we need to use the CID, right? So we can group by CID, but then if I just group by CID, there is problem. I am trying to show the company name. If I group by CID only, then I can project CID plus functions. So let me get this query now. Okay, it shows the values for different company IDs. So CID is the first thing. So 10 and 11, these are different company IDs. For this one we have 4 users, for the other one we have 3 users. So the new company is something different now, but I would like to show the company name as well. Now I need to use a subquery. Otherwise, I cannot include company name as an additional thing here. Actually, one approach could be to include the company name as an additional group by statement. So this is actually possible. If I include the company name to the group by condition, I first group according to the CID. So these Ocean Arts, these 2 different companies will be 2 different things. I then also group according to the company name to be able to just show the company name, to be able to just project that company name. So if I execute now, I will see that for Ocean Arts, we have one with CID 10, we have the other one with CID 11. Actually, this solution is also correct. But some other way of doing it will be to use this one as a subquery. So from this part, I know that I can get the number of users per company ID. And with some other query, for example, let me write select, I would like to show the company ID, right? And I would like to show the count of users, which is going to come from some query that's inside the subquery. And to be able to get the results of functions, it's a good strategy to give a name to them, because otherwise I don't know how to refer to this attribute. So for example, for CID, I can say that, okay, CID, that is coming inside this subquery. But for the results of functions, we need to give a specific name to them. Otherwise, it generates the column name or the result attribute automatically. So let's name it as user count. So this is just one name that I'm giving to the count, these results. So let me actually get this one and show it in queries, create query in SQL view. So if I run this, you will see that company IDs followed by the result of the function, and the column name is user count. If I do not include this rename option, then this column name is count star. Sometimes it could be hard to refer it. That's why I give a name to these results. So coming back to here, from this subquery, I get a set of results. And this result set could actually function as a table. So it's a result set. I can give a name to this result set, for example, groups. And I can use this whole thing as a from table. So from, I can write, this is one company table because I would like to project the company name. So from the company table, I get company name. But from this result set, what I get is CID and user count. So from the groups table, I actually create some result sets, but let's refer to as a table. So from this groups table, I have CID and user count. And since this acts like a table, I can include it next to from. So let me write it like this. So this is a result set. I give the name groups to it. And then, similar to all other queries, I can have additional var statements. So I can write, okay, from this company, CID of it should be equal to the one that is coming from this groups dot CID. And then I can show the user count as well. So what we are doing is actually, let's say that if I were to have some table called groups, I can join these different things based on some attribute. And in that table that is called groups, actually what I find is for each company, I find the user counts. So this is my subquery. In such setup, I can write this. Instead of having a separate table called groups, I actually get a result set from my subquery. This is it could be kind of confusing, and we already saw a correct way of solving the problem. But this is also a correct solution. So some ideas from this query could be useful. So now if I go and actually let me use this one. If I run it, now I will see for each company name the user count and different CIDs, different companies with the same company name are also grouped separately. So that was what we tried to achieve. So this could be a little more complex, but don't be afraid. So this is just one way of solving the same problem. So we have a correct solution if you just include the CIDs for both group by and select statements. But some ideas from here would be useful, I guess, in future, because sometimes we might need to include result sets and join it with some other table. So let's continue then. We also have another question saying that find CID of groups with more than 2 partners. So let's try that. So we would like to show the CID of the groups. So let's say select CID. For groups, again, we need to make the join operations. Maybe it's better to get the subquery. So I would like to select the CIDs. I use these 3 tables. I join them. I need to group them according to CID. But there is one condition. It says that I'm only interested in the groups with more than 2 partners. So the partner count is something that I can compute using this statement. Let me do it first. So I can compute the number of partners per CID or per group. But now instead, what I would like to achieve is that put some condition for the groups. So to put some condition for the groups, we use the keyword having. And if I use this keyword, I can use the results of functions. So remember, with where conditions, we cannot use the functions directly. We need to use subqueries. But then with having statements, this time what we can use is actually functions. This time we cannot use attributes directly. So with such query, if I write it here and execute it, this time you will see that in this execute SQL statement window, the additional part is saying true because it is giving a true for this last condition with having. But you will also see that for each of these company IDs, the number of partners is larger than 2. We can also say that, for example, it can be larger than 4, etc. Then we have less groups satisfying that condition. So one thing that's important here is that if we write having, then we are not interested in the separate attributes. So having credit larger than 2 is not meaningful. It will actually give an error because this credit is not actually a part of our groups. But we can have some functions according to the credit. We can say, okay, for these groups, let's find the average of the credit. For each group, it will find the average of the credit, and if these average is larger than some value, maybe we would like to show that value. And in here we can actually also show the average of the credit per group that satisfies this condition. And if I increase this limit for the average credit, then I start to get less number of groups. So from here, actually, we have additional remarks. So for some of them, let's go quickly. Or maybe not that quick. Okay, then. Since this is the backup video, it's fine to pass the limit of the lab. And actually for the labs as well, we have the additional hours. Neyse, o kadar karıştırmaya gerek yok. So let's continue then. So what we have now is we can also add up different conditions. So actually this is simple, so let me just show it here. This is actually not some exact question. For the criterion on individuals of a group, we still use var conditions, so this is a remark for the thing that we just did. So we can have additional var statements for the groups. So I can say and credit is larger than 200 for the individuals. So this is a condition for the individuals, since it's a var statement. This one is a condition for the groups. So these two are different in that manner. So let me check this one. Now I have more. Why? Because for each group I make sure that the people that I get is having more credit than 200. So it's actually kind of helping for the average of the groups to be larger than 300. So for example, if I write here less than 200, then I will get nothing, right? Because in a group, if I would like to include some person grouped according to the company ID, then that person is also getting credit less than 200. Then I cannot satisfy for groups. The average cannot be higher than 300. But if I write, for example, larger than 300, then for each of these groups that I have, they will have average larger than 300, because each individual is getting higher than 300. So this one is for grouping different or mix and matching different conditions. For example, for the individuals we can have multiple conditions. For example, we can say that the surname should include a capital or small letter A for the same query. And other than selection queries, we then have some other forms of queries that change the data in our database. So in our database, we can have select queries to let's make it a different part of the video.